Okay, so welcome back. In this video, we're going to look at generating some code in Visual Studio and C++ that will ultimately render this ray traced image you see here of all these spheres. And if you've done any investigation into ray tracing, you probably recognize this image. This is a very common image in the ray tracing field, and it is based on some code that was developed by an NVIDIA engineer named Peter Shirley, and he did a very wonderful explanation and website explaining the very basics of ray tracing. And we're going to take that code and we are going to make an addition to it that we are going to get from another engineer from NVIDIA, where he adds CUDA functionality to this software. What that means is that you're using some NVIDIA API called CUDA that allows you to use your GPU to do the rendering. And if you know anything about ray tracing, you know it can take a long time if you do it on your CPU. And GPUs are designed to do parallel processing, do a lot of things all simultaneously and save a lot of time. So we're going to do this image, and we're going to do it on our GPU. Now, a while back, I did a series, a couple of years ago, I started a series talking about ray tracing and computer graphics using C++. And I did like 6 videos in the series. We talked about objects, we talked about images, we talked about UV mapping, we talked about GPUs and what they are and how they work. That was a couple of years ago. Unfortunately, I got basically no views, so I kind of lost interest. But I'm now getting back into the programming of ray tracing in C++. And we're going to start out with this simple ray traced image using our GPU. And hopefully, if I maintain the interest, I'm going to look at, after this, we're going to look at implementing a GUI to give you real-time interaction with your ray traced image. Now, if you look here at this solution for this generating this image, over here on the right, you can see it's really very simple. So the code we're going to use is from this website. I mentioned Peter Shirley, he's from NVIDIA, and back a few years ago, he developed this very simple explanation of ray tracing. And you can see he starts out talking about images and how to save an image and how to do vectors and simple rays and cameras and all that. So really, if you want to learn about ray tracing, I strongly encourage you to look at Ray Tracing in One Weekend. It's a github.io. The extension of that we're going to talk about was done by another engineer named Roger Allen from NVIDIA, and he took Peter Shirley's code and added CUDA. So he's got this technical blog, developer.nvidia.com blog. It's called Accelerated Ray Tracing CUDA. And he does the exact same code, but he adds CUDA so that the GPU can do the rendering and save you a lot of time. And you can see right here, this looks very familiar. This is the image that we're going to be developing using our GPU. And it's really nice because this image that we're going to develop the software for is generated in about 2 or 3 seconds. So it's really, really fast and very nice. And he references Peter Shirley's work and talks about how he is implementing CUDA to do all this work. Now, if you want to get more into CUDA, there's also another technical blog by Mark Harris, an even easier introduction to CUDA in the NVIDIA developer blogs. And that goes through a more simple explanation of how CUDA works. So if you want to get into CUDA, I encourage you to take a look at that. One of the downsides I have with something like CUDA is you're kind of left at the mercy of NVIDIA. It's private code and you can't really look at it. The positive thing is if you have NVIDIA GPUs, you know it's going to work with the NVIDIA GPUs. You know, it's up to you how you want to do it. There's open source alternatives, but we're going to look at this simple implementation of CUDA with the ray tracing in one weekend code and develop this. Now, the other thing I would recommend, if you want to get deep into ray tracing and really understand it, there is a YouTube channel called Quantitative Bytes. And this is really amazing, where he starts from scratch using C++, and he develops code from the very beginnings to show how to do ray tracing. And really encourage you to take a look if you want to get into the details of how ray tracing works in C++, and he uses the SDL library to do the user interface. Very nice. So what we're going to do is we're going to look at how to develop this and how to set this up in Visual Studio, and how to set up CUDA. What we're going to do after this, if I maintain my interest, we're going to look at taking this code that generates this image, and we're going to add a GUI. Now, the way it is right now, it renders this image, but it saves it to a file on your hard drive. And the file it saves is in what's called a PPM format. And this is the file it saves. And it's basically a text file. And it saves the R, G, and B value of each pixel of this image. So it's basically this image in text format with each R, G, and B value for each pixel. So up here, the top left, the RGB value is 217, 233, 255. And this image that we're generating is a 1200 by 800 pixel image, which means that if you multiply those out, it's 960,000 pixels that you see right here in this image. And if you go to your PPM file of that, and if you scroll down, you can see there are 960,003 entries into this text file. And since there's three header lines, you can see each one of these represents the RGB value of 1 pixel. So it's really pretty straightforward. But what we're going to do in the future is we're going to, instead of sending that to a text file, we're going to implement a GUI, and I'm thinking to use IMGUI, which we've talked about before, and that gives you a graphical user interface where you can control, ultimately we want to control the position of the objects and the lights and the camera, and have user interactivity with that, so we can modify things and look at them in real time. So that's the goal. And then after that, I'm hoping to be able to, instead of just rendering simple spheres, I'm hoping to be able to use an OBJ loader, an object loader, which again is a simple text file that defines an object. So say we generate an object in Blender and save it as an OBJ file. That basically defines all the vertices and faces and everything. And I'm hoping we can do that, save an OBJ file and import it into this and render just arbitrary objects. So that's kind of the goal in the near term, to get a GUI, a graphical user interface, and also import objects that we can render. So in order to do this, how are we going to do it? Well, the first thing we're going to do is we're going to download from NVIDIA the CUDA code, which allows you to set up a Visual Studio solution based on CUDA. And then what we're going to do is we're going to go to the Ray Tracing in One Weekend that has the individual header files on GitHub, and it's got these 7 or so header files, and we're just going to copy and paste them into our solution. And it also has this main.cu, which is the CUDA code that allows you to run that, and we're just going to copy and paste that into this solution. And there's only a few, after that, there's a few setup things we have to do to make sure that the CUDA works. And after that, we'll be able to render the scene, save it out to a file on disk, and then in future videos, we'll try to implement the GUI. So to get the Cuda Toolkit, you can just search on Cuda Toolkit or go to developer.nvidia.com/CUDA-downloads, and you'll get a screen like this. Choose your operating system. I'm going to do Windows, and then Windows version 10 or 11. I'm going to do Windows 10, and you can choose the installer type. I'm going to do local, and then you can hit the download. It's 2.5 gigabytes, and you'll get this exe, and you can run it and just follow the on-screen prompts, and it will set it up. And it will also do some integration with Visual Studio if you have Visual Studio. I've got Visual Studio 2022 and it recognizes that. So next we'll go into Visual Studio and set up a basic CUDA project. So now we'll start up Visual Studio, and I've got 2022, and we will create a new project over here. And you will see that if you go up here to select the language, it now has a CUDA in here, and you can start a brand new CUDA 11.6 runtime, C++, CUDA, Windows. Next, give it a name. Now I'm going to name it YouTube and create. And here we have a brand new CUDA project that we can run. It's got the kernel.cu or CUDA, and we're going to replace that. But all we're going to do here is we're going to copy and paste the header files and the main.cu, and we should be all set. We are going to have to make some changes to the project properties. So let's do that first. So the first thing we want to do is go up to the project, right click, and go down to properties, and we need to set up a couple things. The first thing we need to set up is the architecture. You're basically, I think, telling CUDA which architecture GPU you're using so it can set up the right code. So to do that, we go into properties, configuration properties, and then make sure we're set to all configurations. And then we need to, under CUDA C++, you can see it knows we're doing CUDA in C++, we want to go to device, and you can see code generation here, and it has a default of compute 52 and SM52. What does that mean? Well, after some searching, you might find out that that defines a Maxwell family of GPUs. And if you look at the different families of NVIDIA GPUs, you can see they have the Fermi, the Kepler, the Maxwell, the Pascal, and so on, depending on what vintage it is. I'm going to change that because I have a Pascal, which is a GTX 1080, and I have a Turing. So how do we know that? Well, I found this list of NVIDIA architecture names, and it shows what the correct answer is going to be in that code generation for the different families. So I've got a Pascal, so I'm going to do SM60, and a Turing SM75. So we go here, we select that code generation, you go to the drop down, edit, and I'm going to type in compute _60, comma, SM _60. And then I'm going to do return compute _75, comma, SM _75. And that allows me to use either of my GPUs. One's a 1080 Ti, one's an RTX 2070. So I'll hit OK and apply, and now I've set up the right architecture. Now the next thing we need to do is we need to tell this software, if you look at the ray tracing in one weekend, it basically sends it out to a file as we showed before. However, the CUDA version that we're going to copy and paste, what it does is it just prints out to the std cout, which is the terminal. We want to send that to an actual file. So how do we do that? Well, we go to project properties again. Under configuration properties debugging, we want to add a command argument that will send all of the cout that goes to the console. Instead, it will send it to a file. So to do that, we go here, we do edit, and we type in right arrow, and then we type in the name of the file we want. So we can say image.ppm, and that is going to render the image to a ppm file like we showed before. And then we apply that and hit OK. So now we have to go through, we're pretty much set up. We need to add the header files and the correct CUDA CUDA file from the websites. So to get the CUDA ray tracing code, we go to github.com, and this is Roger Allen, Rogerallen, and it's the Ray Tracing in One Weekend in CUDA project. And you'll see here we've got the basic code. However, we're going to go down. Here's the part 1 code, but we're going to go down to the ending code. He goes through the 12 chapters of the Ray Tracing in One Weekend, and chapter 12 includes everything, and we're going to use that. So we're going to go down to chapter 12, Where Next, and it brings us to this project, and you can see it's got the camera, the hittable, the main.cu, material.h, ray, sphere, and vec3h. And that's where we're going to get the code from. So make sure you're in chapter 12. It's got all of the stuff mentioned in the Ray Tracing in One Weekend. So we can basically, what I did is I just copied and pasted. So for example, camera.h, you click on it, and it's got the code here for camera.h header. And you can just left click and drag and copy, and then go into your project and click on this, add new item, and you can add a header file and name the header file and give it the same header file name, and you can just copy and paste it and do that for all 7 of these header files. And then the last one is the main.cu, and that's got the CUDA code that actually does all the work, and you can just rename the kernel.cu and just copy and paste the contents of the main.cu from the GitHub, and you will have this here. So there's probably another way to do it quicker in GitHub, but honestly, I'm not a GitHub fan. I try to avoid it as much as possible. I like to do stuff myself and understand it rather than copying and pasting and downloading. This is one exception, but basically I'm just copying and pasting. And with that all done, we should be all set to try this in debug mode and see if it all works. So before we run it, let's take a look at this main.cu with the CUDA code. It's kind of the main entry point, and see what's going on so we get a good idea for how it works and what we can do with it. So you can see we've got the headers here addressing the header files that we copied and pasted. And here we're setting up a vec3 color. And we've got some random, we've got some render code. We're creating the world. This global void create world is where you specify what you want in terms of spheres and materials. We can look at that a little bit later, but you can see we're adding a new sphere here, and we're going through the list, and we're adding stuff, and we're adding a camera, and here is the int main, and this is where all of the work gets done. And you can see we're defining a rendered image that is 1200 by 800 and 10 samples per pixel. You can modify these, like if you want a 4K image and you want to see how fast it goes with big images, you can modify these numbers. And you can see we've got an STDC error that goes to the console. It says rendering an NX, a 1200 by 800 image with 10 samples per pixel in, it's the number of blocks, X and Y blocks. And you can see that it's going to send that out to the console. And we're doing some other stuff here. We're making our world of hittables and the camera. And we're doing rendering. And here you can see that there is an output to the console, see error, that says how long it took in seconds. And what we're going to do is we're going to do Control F5 to run this, which will serve to keep the console open after it's complete, so we can see this answer to how long it takes to render. Okay, and then the other thing, output as an image, and we're going to send some stuff to see out, and since we did that redirection, it's going to send it to our ppm file, and it's going to loop through every pixel here, and it's going to send to the ppm file cout IR, which is the red value, 0 to 255, IG and IB, and that's what we saw in the ppm file, the values. But we've redirected, instead of console, it's going to go to the ppm file. So what we can do is we can start with debug mode to see if everything works. Now keep in mind, debug is going to be very, very, very slow. When we run it in release mode, if everything works, we'll run it in release mode, and it'll be much, much faster. So I'm going to do Control F5 to run this. So here's the console window rendering a 1200 by 800 image with 10 samples per pixel in 8 by 8 blocks. We said before that's 960,000 RGB values, one set for each pixel. And this is going to take quite a while, again, because we're in debug mode. You can see it took 28 seconds to do it in debug mode. So press any key to continue. And now we've got that done, so we know everything's working. So let's go into release mode. And keep in mind it was 28 seconds. Let's do that again and see what happens. Rendering an image. Done. Took 2.71 seconds. So you can see that it's very, very fast using the GPU, and it's that very complex image we had before. So that should be it. That should, hopefully that works for you. And we can use that now for next videos to be a springboard. You can see we got some very simple code. We can use it as a springboard to add some more functionality. So if you like any of these videos, I encourage you to hit the like button and subscribe, hit the bell notification, and please, most of all, let people know that we're here so we don't go for 2 years without getting any views. Really appreciate it. Otherwise, take care and have a really good day. Thanks.